The airport simulation is defined by 5 different groups of people that will actually define 5 different groups of queues. One of them is the air personnel. Basically, the air personnel will be on their own queue because no one is overcome the other one, and they go directly to check-in and then to security. The second group, it will be the security person that is going for payment. They will actually have a queue and they will have to check if there's air personnel on the queue. If it's not, they will go directly to check-in. Otherwise, they will hold. And these people, after that, they will be done because they don't go to security. The third group of people will be the passengers that have been already checked in. They have their passenger queue. They will actually have to check if there is no personal, air personnel, or security with payment looking for in the check-in. After both queues are empty, they go directly to check-in and then security. There also are passengers that don't have tickets, so they go to the ticketing queue where they have to check if there is no employee going for payment. If that queue is empty, they go directly to the ticketing process and then they regroup with the passenger queue. Finally, there is the employee looking for payment and they don't actually wait, they go directly for the ticketing, and that will be the whole set of people that will work. For what kind of expenses are associated with the sequence of events, there are actually two main possible expenses associated. One is at the time on the plane waiting for passengers to access, and the other is the cost of people at the attending checkpoints. What are the reasons to build such a simulation? Well, they're actually to predict bottlenecks, to estimate timing, and also to minimize the number of people at the checkpoint to attend all the different passengers or people going through the checkpoint. For the question if building a simulation is appropriate for this example, the actually answer is yes, because the cost and timing to recreate all the possible iterations overcome the cost and time for the simulation, and the capacity for the simulation to expand according to the airport is actually straightforward. As the airport grows and at different checkpoints, the simulation is capable to recreate without any problem. What are the main questions that we answer with this simulation? Basically, the time for all the possible scenarios. Basically, which are the worst timings or actually the best timing that we can approach for each scenario, and the best resource arrangement. This actually means the best setup on the or the personnel at each checkpoint. What data structure is used to implement the queues in this simulation? I think basically a list of priority queue could be the very effective in this case, basically because lists can actually detach nodes as they can be in the queues because people can actually get out of the line. And second, a priority queue because even in there are actually in different groups and different queues happening at the same time, it can be some kind of priority. Example, for elder people to go first. In some cases, just for the passenger queue. Finally, what other additional variable could be actually added, or what other outcomes could be added on the process? I would say the first case is the handling of family groups. This could actually affect the speed of the event, basically because a whole series all connected passengers will be need to attend by one specific person on the checkpoints. However, when they are going through the security, they have to go one by one. And the other is the difference between paper and digital access. The paper trail could actually slow the time, or the difficulties with the digital access could also slow the process.